Hi everyone, I'm George Jackson, and today's 5 questions are with a very distinguished group, Dr. Tommy Gardner, Chief Technology Officer over at HP, retired Rear Admiral Doug Small, and there on the end, Neal Byrd, VP of Federal at Latent AI. Admiral Small, I'd love to start with you, sir. Today we're talking about AI at the tactical edge. Recent DoD initiatives have really hammered home the importance of AI at the tactical edge. Talk about where they're needed most, where industry is plugging in right now, sir.
Where they're needed most is almost everywhere. There's a few examples of places where AI could really help at the tactical edge, and where industry can help is in getting those AI developments, which to date have really been driven by things like cloud computing and massive infrastructure, to take those types of models and make sure that they can be deployed at the tactical edge. I mean, that is really the critical piece, is kind of bridging that commercial use into a military use in a disconnected environment.
So Tommy, we've talked a number of times about how rapidly this field is evolving. A few areas I pull out today: operating environments, power limitations, security requirements are areas where the U.S. military faces some unique constraints. How do you work around some of those so that you can leverage that AI at the tactical edge to its maximum potential?
I think the advances in technology, specifically in the hardware side, are giving the military the opportunity to put the latest and greatest chipsets that will have an NPU, an AI computer. And I think within 3 years, the only computers sold are going to be AI computers, because the neural processing units can process about 10 times faster than the graphical processing units we're using today. And they do it at 90% less energy. And so the energy use being down, the processing speed and power being far exceed what you have, is going to make the soldier and sailor at the edge much more powerful in their decision making and process. So you add that increased hardware and you put it together with some of the modern software. A lot of it's being written by AI now. I'd hate to be a software programmer today and think I would have a job next year, because you might get replaced by a chatbot. So, and they write some pretty good code. So I think you're going to see the change occurring, and you combine AI and the 32 different fields I count in an AI world with quantum information science, and you come up with quantum machine learning. And that field is taken off like wildfire, because we have the processing power we didn't have just 2 years ago, and we have storage capability that's beyond imagination.
2 key mission objectives, I'll call them, Admiral, around what Tommy's talking about are accessibility and scalability. These technologies need to be accessible to everybody at the tip of the spear, and they need to scale in a way that's efficient for the Department of the Navy and other military branches. Could you talk about how you execute, how you deliver on that? What do the services need from industry or from their sort of complementary units to make that happen?
I think the accessibility part, actually, Admiral Kaler talked about it some this morning, about the exercises that they run. And so getting companies to get directly involved with sailors in exercises and experiments and things like that, see the problems that they're trying to solve and help them solve them in real time. I mean, that gives you the accessibility. It also teaches military people what is available in commercial industry. And so just kind of, closing that knowledge gap, for one. In terms of scaling, then how do you take that capability and put it in a lot of different places in a short amount of time to me, that's another page out of sort of commercial industries book. Abstract that software capability from the underlying hardware, notwithstanding the improvements in hardware that are coming, but abstract that so that you can move the software at a speed that matters.
Those edge environments, Neal, are challenging for a number of reasons. A few before we went on the air that you called out: limited bandwidth, harsh conditions, need for low latency. I'm sure there are many, many more. Can you talk about some of those challenges and how DoD can overcome them?
Technical challenges are really wide, particularly the further or closer you get to the edge. You're in environments where you have poor communications or no communications, and you have to find ways to make sure that everyone's on the same page and operating at the same speed, particularly when things get kinetic. So technologically challenging, it starts really with trying to take something that's really complex and make it usable for everybody that touches it. So when we're talking about sailors and soldiers and airmen, how do we make this capability consumable to a push button or something that they're used to working on in their everyday life? That's the first challenge to overcome. And then at the technical level, do you have the compute, do you have the power or the bandwidth or the storage capability at the edge to take all these great advanced models that we might be building back at the headquarters element and push it out to where our edge elements could actually take advantage of them? So how do you optimize that and make it small enough to be consumable and then get it deployed really, really easily?
You heard Admiral Kohler talk this morning about autonomous systems and the drive to have a hybrid fleet where you've got people and ships, but autonomous air, sea, and subsurface. And the AI tools we have, both in software and the hardware advances that are here today, are going to change the understanding of what autonomous systems can do. And it's been around for 20 plus years of having systems that go out and operate. But now the decision making and the intricate details that you could program in by the use of sensor data, understanding the environment, it's going to be a whole world different applied to the battlefield.
As we come to a close here, I'd love to talk a bit about partnerships, do a round robin if we could. Tommy, I'll start with you. It's clear here at West 2025, this is an entire ecosystem. You've got, all of the military services represented in some form or fashion, a number of other agencies here at the table. You've got key industry partners. What do you pull out of partnerships to really drive tactical edge AI up the battlefield?
Well, if you're not working together, you're inefficient. And when you go into a program office, you ought to see the government, the contractor, and the subcontractors all working towards one mission. And in the submarine force, we called it Team Sub. And it really was a team. And we understood in the government that we relied on our contractors, and they had to be healthy, and we had to help them solve their problems, and totally dependent to have them solve the problems we had in warfighting. And so from a public-private partnership plan, if you're not working as a team with a central mission of improving a warfighting capability, you're missing out.
Admiral, anything you'd like to add? Something you want to foot stomp there, sir?
Sure, I'd say, I'd add to that mix, given the modern software methods, sailors and actual operators of systems should also be in that consideration. And that kind of gets to Admiral Kaler's point. And then where industry can help is take from the sailor and the use of that edge AI software application all the way back through the entire AI operations chain, back to data storage and everything else. That whole chain needs to be built out for any of those applications. That's where we need a lot of industry help and need to move at the same speed and scale that they have to get that done.
Neal?
The industry is a team sport. Warfighting is a team sport, all the way from the public-private relationships and partnerships that we have out there. It is incumbent on all of us to listen to each other and make sure that we are not building requirements because they're cool engineering things that we can do, but we're building requirements that are actually going to be usable and push the mission forward.
And AI is dependent on data. If you don't have secure data, either post-quantum cryptography, or you have cybersecurity where you can protect the privacy and the intellectual property of your data, we're all lost. And so you can't just have AI to solve problems, but you have to have secure data that's validated, clean, and ready to be used to get good decisions out of it.
Well, it's been a great 5 questions as a team sport. This panel of luminaries, Dr. Tommy Gardner over at HP, retired Rear Admiral Doug Small, and Neal Byrd over at Latent AI. Gentlemen, thanks so much.
Thanks for having
George.
us.
Audience, thank you for watching. That was today's 5 questions. Before I let you go, a real treat. We've done the tell. Now we're going to do the show with Ryan Fantus over at Latent AI, talking about edge AI capabilities. Ryan, take it away, sir.
Hi, I'm Ryan Fantus with Latent AI. Today we'd like to show you a couple of different capabilities that our tools can help bring to operators working out in the field at the edge. The first demonstration we'd like to show is one that is in a ship harbor. Essentially what the operators need to do in this case is deploy a sentry, which is represented by this screen, by this video playing right here. And that's supposed to be a live feed of ships in a harbor. The operators need to be able to see when ships are coming in without manually staring at the screen. They need to be able to see callouts, need to be able to have data about that. This model that's running right now actually is not detecting anything. You can probably see pretty clearly that there are no bounding boxes, no detections. This is something that you can kind of expect when a model ships from a higher headquarters and then gets out to a location where they don't have the actual data needed for that operational environment. Right now, this model is not meeting our operational needs. It's not showing any sort of detections. And so the operator at the edge needs to update this. Typically, that would consist of deploying an entirely new model. So that could be up to 500 megabytes, sometimes even more. In this case, what we want to do is we just want to patch the model that's running in memory. So what we have here is a patch, and you can see this patch is about 22 megabytes. So that's going to save a lot of bandwidth. And you'll see also it saves a lot of time with actually patching an already running model. So right now, this model is actually being patched with that new update that we've just deployed. It's patching in the background, requires 0 cognitive load from the operator. And you'll see that in almost near real time, the model starts detecting things as we expected in the first place. So we basically took a 500 megabyte model. We didn't have to reship the whole thing. We just reshipped the little tiny bit that was required to make it do the functions that we needed it to do. And so that essentially concludes the first portion of the demo. So let's go ahead and move on to the second portion of the demo here. The second portion of the demo, just like the first, is running just on an HP ZBook laptop. It's not running on a GPU cluster or anything. And what we're using in this case is we're trying to make the LEIP products help operators create labeled and curated data sets. The reason that this is important is because without a labeled and curated data set, you can't retrain a model. But a lot of times it's difficult to get a new data set that is labeled and curated. And oftentimes it requires a lot of images, a lot of processing, and a lot of mental bandwidth to actually go through every single image and update, label it. And so I'm going to show now how we try to make it so that operators don't devote that much time and effort to doing the same work. So right now what we're looking at is basically the ocean floor. This is a side scan sonar. And the intent here is to find objects that are along the ocean floor. What we eventually want to do is we want to categorize these objects and use those as a labeled data set for a retrain purpose. So we'll start with this find everything function from the LEIP tool. The find everything function is basically looking at the ocean floor and is saying, show me everything that doesn't belong here. Show me everything that's not just ocean floor. And so you can see, for example, that we've got an object that has been detected here. And it's an anchor in this case. And so let's say that we want to add anchors to our model. And we know that we've got a large data set. We'd like to see if we have any additional anchors that we could label with as little cognitive load, as little manual labor as possible. So previously we used the find everything function. In this case, we're going to select this anchor and we're going to find similar. So now instead of looking at the results of find everything, we'll look at the results of find similar. And again, it's honing in, it's indexing on that anchor shape. It's looking for things that look like that, resemble that. So one thing we want to do is manually set a threshold. This is where we still keep the operator in a loop. We still want the operator to say, this is within maybe 80% accuracy, similarity to that initial object. To me, that's probably good enough to start looking through some of this data. So we can change the confidence level manually. I set the confidence level around 80%, and you can see that really shrunk the potential data set. So now I can go through and I can manually look at the resulting data, and I can curate that and label that as needed. So I can click through and iterate through each one of these images that it pulled out, confirm that the similar object is actually an anchor, and then I can apply the anchor label to that data set, extract that, and use that for my retrain. So that concludes what we'd like to show today. Feel free to check out more on our YouTube channel, look for Latent AI, or check out latentai.com. Thank you.